Atal's FTP. Okay. So, good morning, all. Welcome you all for this final day of Atal sponsored AACT FDP on integration of renewable energy with big data analytics and artificial intelligence. So, wish to thank the organizers, Dr. S. Vijay Bhaskar, Professor and Head, Department of Tripoli, and the organizers, Vinod Kumar sir. And I wish to thank our principal, Dr. T. Manigandan, for giving me this opportunity to take this talk on integration of renewable energy systems. Okay. So, with using of big data analytics. So here my presentation will completely deal with the practical perspective and also quite a MATLAB simulation perspective about the works what I'm doing. It would not be a general topic. It would not be a general. So it will be having a lots and lots of opportunities in publications and paper segments. So I wish to make this particular thing in order to understand the nuances available in the integration of renewable energy systems. If you have any queries, you can please put in the chat box. I'm ready to answer all your queries. And my request is, if my voice is not audible and if my presentation is not visible, you please contact me through my number. So because due to rain, the internet may be quite disturbing, but anyhow, I will manage for that particular thing. But if there is any disturbance, please inform me. So let me share my screen. So for my presentation, so hope you can able to see my screen. Yes. Okay. So this is my screen. Okay. So I can make it as a complete slideshow. So here is going to be on my presentation about integration of renewable energy with microgrid. So here I'm going to deal more thing related to the part of microgrid. Okay, so we are going to see normally we do know that so we do know about the renewable energy, the basics of renewable energy, because I don't want to grind the same concepts again and again. I want to tell you what are the problems available in the existing microgrid, how to convert the conventional microgrid to a smart grid, and what are the works can be done in this microgrid. Okay, so this in this perspective, we are going to deal the things. Okay, so where we can able to understand about the various concepts related to this microgrid. So, okay, let us see. Okay. So here we go. That is about the concept. So from the list of topics which I'm going to cover for this presentation on the concepts of big data analytics, because this topic is quite related to the data analytics. Okay, and then I'm going to give the differentiation between the microgrid and smart grid, and how to integrate the renewable with the grid. It is not an easy task. Okay, so in a simulation we can able to perform, but in the hardware it is quite difficult. So in order to concentrate on the grid integration of renewable resources, okay, so we have to check at each point and what are the problems available, and then I'm going to give the thing of. Okay, so we can able to give that applications of the power electronics, the grid integration, and we are going to discuss about intelligent systems. And I'm going to give the case study of different faults that has been available in the microgrid, and finally having the concluding remarks. So the schematic view of big data analytics, because this FTP is completely based on big data analytics. It is not basically on the renewable energy. It is basically on the big data analytics. Okay. So normally at present, so when we speak about the normally we have to see that kind of topics. Okay, so where we can able to understand that it is quite related to the people, those who are in the things like computer science or information technology. Only those people will be deal on the big data analytics. No, it is the common term. Any part of engineering people can use big data analytics. So when we speak about the sliding contact, each and every, this is the complete building block. Okay. So in this building block, the major factor, so the person who is hiding from the big data analytics is the artificial intelligence. Okay. So we know that, that is the natural intelligence of the human brain. we are going to create the artificial intelligence. So for creating the artificial intelligence, what is the major requirement? The requirement is data. The data is very, very important. What is the meaning of data? Data means information. Okay, so we are getting some information from the either from simulation or either from the experimental setup. We are getting some information. Okay, so normally we will collect some set of data. So let us say that the data is equal to n. Okay, so it depends upon our work nature. Your value of n will be like 50, or it may be 50,000, or it may be a 1 lakh data. It depends upon the thing. Either we can able to take the data with the experimental data, or a simulation data, or a field work data, or else with the questionnaire data, or else by with the help of mathematical modeling, we are collecting the data. So this the collection of data is first and foremost thing for making this artificial intelligence. So now I'm going to tell some stories. Okay. So now I'm going to tell a story about the data. So for an example, so this is a small story about the data. Okay. So for an example, let us say that a mother. Okay, let us say that she is a mother. Okay, and this is a small kid. Okay, so let us say that it is a small kid. So both are there available. So let us say that what is the objective of this particular problem? Okay, so let us say that we are having a mother and we are having a small kid. Okay, so the objective of the problem. So the problem formulation is okay. So this shows some of the concepts of the research methodology as well. Okay, so the problem statement. What's the problem statement? The problem statement is okay. So the mother likes the kid to eat of its own. Okay, that's a problem. Okay, so she is fixing the problem. Okay, so what she's doing, so the mother wants the kid to eat the food of its own. Okay, because till now the mother is feeding the kid. Okay, with the help of her hands. Okay, she used to take the food and she will be showing all the nature, and she will be showing the moon, and she will showing all the balcony things. So after showing that, she is making the kid to eat the food. Okay, so now what is happening? The kid is very happy because the mother is taking the kid outside and she makes the kid to eat. One fine day, the mother is telling to the kid, "You have to eat of your own." That is the problem statement. Eat of your own. Okay, so in order to meet this is the problem statement. Okay, so after finding the problem statement, she has to fix the objective. Okay, so the objective is how to make the kid to eat of its own. Okay, so she's making the action verb. Okay, to make the kid to eat of its own. To eat. How to make the kid to eat of its own? Okay, the first and foremost thing is the mother want to teach the kid. Okay, so the mother want to teach the kid. Okay, so how she will start the teaching? So mother, what she will do, the first step she will say to the kid. Okay, so from tomorrow onwards, you have to eat of your own. Okay. Normally, the kid won't accept this. Okay, whatever the mother says, the kid will not accept this. The second day, what the mother will do, she will say that, look how I am eating. Okay, look how I am eating. So what the mother will do, she will take the food on her hand, okay, and then she will show that you have to take the food on your hand and then you have to eat in your mouth. Okay, so this information will be shared to the kid. Okay, this is called as the data number one. That is the information is passed. Okay. Who is making the data? The data is being generated from the mother and the data is being given to the kid. That is the data number one. So the kid is not accepting this one. Okay. No, she's throwing the food. She is making the food throughout the room. So the third step, what the mother will do, so she will take that, that is, see, you are doing some mistake. You should not eat like this. Okay, you have to eat like this. So she's sending another set of data. That is data number one. Like this, each that depends upon the nature of the kid. That depends upon the mind velocity of the kid. At the end number of tasks, the kid will start to eat. That means the objective of the mother to make the kid to eat is fulfilled. That is called data. Okay, so now we can able to see what is meaning of data. Next, what is happening? So the mother is teaching. What is meant by teaching? So here we can able to see more number of teachers are participating in this program. What is meant by teaching? Teaching is not just saying the Ohm's law, let us say that this is a teacher and this is a student, it is not just telling that, that is, this is Ohm's law, this is Kirchhoff's law, this is Lenz's law, this is Faraday's law. It's not like that. Okay. Some students may accept, some students may not accept whatever we say. Even we are crying for full semester about what is going to be rectifier. But when you're asking about what is going to be a rectifier, if the student says that it is a DC to AC converter, means whatever is said about rectifier, it's all waste. Because the student is saying the wrong answer. Means what is when we're teaching means, okay. So whenever, let us say that we are having a neuron structure like this, okay. So the mother is saying that you have to eat of your own. Let us say that she is telling the task of n is equal to 1. So this data, what it has to do, it has to reach the nucleus. Okay. This is the center part of our neuron. Okay. But what is happening in between the dendrites and in between the nucleus, there will be some gap will be available. This is called as gap. This gap will be available. So when the mother is giving some task, okay, so if it reaches to nucleus only, it says that the kid is quite understanding, the kid is quite hearing. Okay, but the kid is not responding. That means what is happening? There is a gap in the synapses. This is called a synapses. So what is the role of a mother means? Okay, she has to clear this particular gap. Even in our class, we are saying about what is meant by rectifier, okay, or what is meant by inverter. So if this task, if this rectifier or inverter, if it reaches to nucleus only, that means the students is quite understanding. But whatever you are saying, it is not crossing the synapses. So none of the thing is reaching to the nucleus. We feel that the students are quite open their eyes, but none of the things are moving to the nucleus. So for this particular problem, what the mother will do, so in order to clear the synapses, okay, what the mother will do, she will take some steps. Okay, so what are the steps she will take? So either she will scold the kid to eat of its own, or else she will ask the kid, she will even beat the kid. Okay, you have to eat your own. Or else some other, what they will do, so they will compare their kid with some other kids, see how they are eating or how they are eating. Some of the mother, what they will do, so they will please the kid, please eat, man. Or some of the mothers, what they will do, they will cry to the kid, you please eat. I'm having so many tasks like that. So these are the various mechanisms what the mother will take in order to make the kid to eat of its own. Okay. So what are these things? No, this is called as algorithms. These are called as algorithms. Okay. So that means to meet your objective, you are following some steps. That is called algorithms. So with the help of this algorithm, what is happening? So the kid will take some time. Okay. And then what is happening? The synapses, what has been mentioned, it will be get clear. So whatever the things the mother is saying, it will reach into the nucleus. So now once the kid is going up, okay, at that time there is no blockade in the synapses, whatever the mother says is reaching to the nucleus. So now we have understood that what is the literal meaning of data and what is the need for a data to process in our neuron and what is meant by an algorithm. Okay, so that is the concept of this artificial intelligence and big data analytics. So whenever you want a particular system to operate with 0% accuracy, with 99% of efficiency, because always we do expect that efficiency to be more than 90%. So you can even work with some 3 data also you can able to work. Or else you can able to work with 4 data also you can able to work. But whenever you are having the big data, you can able to see that the more number of accuracy can be achieved. Okay. So this artificial intelligence can be subordinate with this related to machine learning. That is, we are making the systems to learn. It is called as a system learning. That is called machine learning. What is meant by learning? Learning means the tuning is called learning. How the mother is tuning with the help of some various algorithms like scolding or beating, or with the help of some comparing with other kids, or pleasing, or even crying, or some others. What they will do, they will combine all the things. Only thing is that they can able to reach this particular task. Okay, so the only thing is they want to do this particular thing. Okay, so that is called learning. So in our teaching learning process also, teaching means it is not called as what the input you are giving they will receive by the students. What is meant by teaching? Teaching is called as a tuning. So for certain kids, scolding will work out. Certain kids, beating will work out. Certain kids comparison will work out. Certain kids pleasing will work out. Certain kids crying will work out. So we have to check which system we are going to adopt which algorithm. So by this only, we are making use of so many things related to the algorithm formation. So for an example, if you want to reduce the THD, or if you want to work with the reactive power control, if you want to work with the integration of renewable systems, we are using different set of algorithms like genetic algorithm, particle swarm optimization, like weak colony optimization, ant colony optimization. Why we are using this? In order to meet the objective. Okay. So why we are using that objective? Why we want to reach the objective? That is, we want to tune it. Okay, so before the tuning, it will be, so that is before I'm giving the algorithm, before I'm adopting the algorithm, what is happening? So my efficiency is just 70%. After adopting, my efficiency is increased to 80. After using a hybrid of this algorithm, I'm getting the efficiency of 90. So now we've understood that how to formulate problem and how to create the objectives and what is the data and how the data is required, what is meant by algorithm. So now, making use of this particular phenomena, we can able to see that deep learning. What is deep learning? That is, in normal learning, we are having only one set of tuning, okay, one stage of tuning. If you are having the multiple stage of tuning, that is called deep learning. Very simple term. So this one, the students will study the deep learning subjects for 5 units, but the concept is only one. You see, what is the concept of artificial intelligence? With the help of the data, you are tuning. That is called artificial intelligence. What is machine learning? You are making the tuning phenomena for a system. What is deep learning? Deep learning means you are using multiple stages for tuning. Okay, that is, for example, even this particular thing. This is a normal way of learning. When a mother, she is asking the kid to eat of its own. For an example, the mother is tuning at the first stage. Father is tuning at the next stage. Grandfather is tuning at the third stage. Grandmother is tuning at the fourth stage. So the number of tuning is increased. Why? In order to make the kid to learn. So for an example, one teacher, she is teaching or he is teaching, and the same student is going to the tuition to study, okay, to get the more inputs. What does it mean? So one teacher is enough. Why the teacher is going to another teacher in order to improvise? So whenever the tuning is going for one by one, that is called deep learning. Okay, so deep learning means it is not studying very deep. It is going with one by one stages. Okay, like that before going to if the student is writing only one examination, it is normal learning. If the student is writing multiple examinations, means he self tunes itself to reach the goal. Our ultimate objective is to improve accuracy and also to increase the efficiency with the reduced losses and also reduced complexity. Okay. So these kind of tuning can be classified into 3 types. One is called the supervised learning. Supervised means if you know the target, it's called supervised. Unsupervised means there is no target is available. Okay, based upon the tuning, what the thing is available. Reinforcement learning means based upon the given condition, you are forcing the system to make. Okay, so that is what really happening in this particular thing. Okay, so that we can able to make that how the tuning has been takes place. So based upon these principles and based upon these ideologies, we are going to deal how we are going to use these principles for our renewable energy integration. Okay, so with this schematic view, even I can teach for the 1 day or 2 days related to this programming. But since we're having the limited time, I'm giving the definitions what is what. Okay, so to get the clear understanding. Now, these are the various possible applications. As I already mentioned to you that each and everything or building block are related to one by one. Okay, like artificial intelligence, machine learning, and deep learning. So these 3 forms are collective of the big data analytics. Okay. So now we can able to see the comparative analysis between the, let us say, okay, if there is a, okay, so I can able to see some chat items. If there is any doubts, you please put in the chat box. Or if my screen is also not visible, you can put in the chat box. Okay. Okay. So fine. Yeah. Now the slide is visible. No problem. Okay. So here you can able to see this is an difference between data analysis and data analytics. Okay, what is the difference between data analysis? Analysis means where the data scientists they will work with the analysis. We will collect a set of data. Let us say that I'm collecting a set of data of 50 data I'm collecting with reference to voltage and current and frequency. Okay, so what the data scientist will do, they will make the data analysis. Okay, so they will draw the graph between voltage and current. Okay, and they will make that algorithms, and they will use the machine learning. Okay, so normally the data scientists, they will use with the MATLAB. Okay, and then we can able to use with the R or Python or LaTeX or C++ for the data scientists for analyzing the data. Let us say that what the data engineers will do. Okay, so the scientist is different, engineers are different over whenever we are processing the data, because we cannot say that all the 50 data will be very good data. Some data will be useful data, some data will be useless data. So we want to make some database. Okay, so both these engineers, like data scientists and the data engineers, they have to work in unison in order to give a complete picture. Okay, so whenever we ask people how you collected the data, sir, we have taken the data from base paper, sir. Sir, we have taken the data from the internet, sir. We have taken the data from the repositories, or like that. The people will normally tell, but we want to take the data and we have to create some reliability on the data. Then only our algorithm will work. Then only we can able to say that that process, the project will work well. Okay. So even the example what I said, so even the work what I said, so we can able to take that, we can able to understand how we can able to. Okay, so we can able to create this data patterns and data analysis. Okay, so based upon that, we can able to create the network. Okay, so the data engineers, they will create some database and data warehousing and intelligence. So here only the data scientists will normally use the Oracle, Hadoop, SQL Server, Hive, and they will be normally using the JavaScript. Okay, so they will be creating a window by which the data can be a prediction analysis like that. But the data scientists, so here our electrical engineers, we normally comes under this category. So with the help of the data, we using for our research, for creating the algorithm, for writing the program, so that we normally use the MATLAB for the processing of data. Now, okay, so now till now I have given some introduction about the big data. Okay, so here we are going to see about how these big data concepts, okay, how the concepts of this big data can be widely useful for our electrical systems. Okay, so normally, since the time is limited, okay, so I want to cover both the concepts, okay, big data and as well as the grid. So here we are going to see that, so because just making a solar panel and creating a DC-DC converter with a MPPT or inverter, so those research works will not result in a very good publication scope. Okay, so for a very good publication scope and the project ideologies, we want to make some concepts of grid connections. Okay, with the real-time environment. Okay, so in my project, in the earlier projects, I created the basic microgrid. In the present project, what I'm doing, so I'm doing converting the microgrid to a smart grid. So what is the difference between the microgrid and a smart grid? Okay, so for that, I'm going to give another one small story. Okay, so before this particular pictures, I will be giving some small story. Okay, so this story will be helpful for us in order to understand. Okay, so here the picture shows that that is, it is a normally a grid system. Okay, so here the line which is marked as a, okay, so here the line which is marked in the green color. Okay, so that will be called as my normal grid. Okay, so the green color. So normally the energy is power is generated with the help of hydroelectric plant or a thermal plant or an industrial power plant or a medium-sized power plant. So we are not focusing on the generation part. Okay, so we are not focusing on the transmission part. We are focusing on the distribution because we are dealing with the renewable energy. Okay, so even though the renewable energy is a source, okay, it is not a source where we are going to transmit to a long distance, where we are dealing as like our thermal power plants. Okay, so that is you making use of a single line diagram. So no such single line diagram concepts we are going to deal with. Okay, we are going to deal with this renewable energy. So here we are going to focus. Okay, so how we can able to. Okay, so with the help of how these things will be given with the help of renewable energy systems. So normally the renewable energy systems will be quite dealing with our distribution environments. Okay, So here in this distribution environment, we can able to see how this particular thing plays a vital role. Okay, so here we can able to see, wait, share the screen once again. Okay, because of this picture, it takes some time. So in the distribution environment, we are going to connect the solar systems or wind energy systems to the grid. So here in the grid, there possess some problems. Okay, so that problems we normally call it as a like various category. So let me share the screen once again, because of the certain pictures, so of the things, it will take some time. So let me share the screen once again. So here we can able to see the literal problems that was being available with the conventional grid. So this is all the problems. That is, most of the grid in our India, it is quite old. Okay, it's quite old, which has more than 35 years of age of the grid. Okay, and also the power plant age is also more than 35 years. Okay, when we speak about the Mettur thermal power plant, and most of the power plants in India, they have been constructed more than 35 years ago. Okay, and also it is quite dirty in the sense we call it as that is related to. Okay, so the 30 means, so that is most of the grid, it is quite, what else to say? It has been given as a dirty environment, means the quality of the power is not that much of our expectation. And also we can able to see this power delivered is quite inefficient. For an example, if you generate the power of 100 volt, for an example, we can able to see that, we can able to get only about 65 volt at the output. That means what? 35% has been given as a losses. Okay, so we can able to see that most of the power is also lost. So you can able to see the transmission, the distribution losses is also keep on increasing. Okay, so earlier it was 18%, now it was 23% and 24%, and the maximum level of delivery is about 35%. And also, whenever we are making the improper connection of grid with the renewable resources, we can able to see it is comes under the category of worst blackout. Blackout means the complete shutdown. Blackout. Okay, so the complete shutdown. So where we experienced this in 2012 in India. So where these are the top 10 blackouts because of the improper connection of the grid with the distribution systems. So the problem is not simple. The problem is very big. So after this, people have been worked out with the various topologies. How to make the grid to be smart, how to make the grid to be viable, and how to make the grid to be useful without this particular problem. So based upon that, the people are working with now on microgrid. So what is meant by a microgrid? So microgrid is a small scale standalone autonomous system. It's a standalone autonomous system. So where the system will be combining with generation, load, and also storage for the local customers. Okay. Here the power is generated by the community for the community, and if there is a power is quite excess, means it will give to the grid. If there is a demand, it means it will get from the grid. Okay, so the size of the microgrid can be ranging from small microgrid to in very big industrial park. So for this, I'm going to share a very small story. Okay, so I'm going to share one small story. So for that, I can able to open one blank screen. So by that I can able to show that story now. Okay, so this story is quite interesting. Okay, so that will be helpful for the for us to explain to the students as well. So here the story is called as a milkman story. Okay, so first let me explain you about the milkman story. Okay, so to explain what is meant by the microgrid. For an example, in a village there was one milkman. Okay, so this milkman is having two cows. Let us assume that this is cow number 1. Okay, this is cow number 2. Okay, so each and every cow, okay, has the ability to give 10 liters of milk every day. Okay, so totally with the help of 2 cows, you can able to generate 20 liters of milk per day. So with the 20 liters of milk, what the milkman is doing is delivering the milk for 5 houses. Okay, let us assume that it is house number 1, this is house number 2, and this house number 3, and then house number 4, and then house number 5. Okay, So each and every house is having the requirement of 4 liters. Okay. So 4 liters for them, 4 liters, and here 4 liters, and here 4 liters, and here also 4 liters, and here also 4 liters. For an example, if there is 20 liters means there will be some plus or minus, the milk will come. Normally the milkman, what he will do, he will add some water or whatever it may be. So the excess milk he will use for his purpose. Okay, so that is the thing. So this is the normal typical life of a milkman. Okay, so each and every day, what he will do. Okay, so what he will do, so he will take the milk. He will take the milk. Okay, so he will move on to the cow and he will take the milk, and after getting the 20 liters he will be giving the milk to all the 5 houses. Okay, so this is the lifestyle of a milkman. Now what is the problem in this particular milkman story means, for an example, let me take this house number 2. Okay, so let me take this house number 2. He is saying that okay, milkman, I don't want the milk for 2 days. I don't want this milk for 2 days. We are going to our native. Okay, so we are going to the native. Okay, so what the milkman will do, so he is having the excess of this 4 liters of milk. Okay, excess of 4 liters of milk. So what the milkman will do, so he will take that 4 liters of milk. Okay, that 4 liters of milk he will take and give it to a place called, in every village we are having a milk society. Okay, milk society, he will give the excess milk. Okay, what the society will do, the society will distribute the milk to the peoples or to the other shops or any establishments. The society will do that particular task. So the excess milk, what the 4 liters of excess milk, on that day the milkman is giving to the society. Okay, now in another fine day, what is happening? Okay, in another fine day, what is happening, so let us say that here the house number 4 is saying that, milkman, okay, in my house my relatives are coming, so I need some 6 liters of milk extra. So totally I need some 10 liters. Okay, 10 liters of milk. Okay, so what the milkman will do, he cannot able to, because the cow is giving only 20 liters. He also want to meet the demand of all the houses. What the milkman will do, his only choice is about this society. So from the society he will get the excess of 6 liters of milk, and he will give the milk to the house number 4. Okay, so this is what is really happening with this milkman story. Okay, so but here the problem comes, where the problem comes means, let us say that he is a milkman number A. Okay, he is milkman number A. So the milkman number A, he is giving the excess of milk to the society. Okay, so in the society we are having the big container. Okay, so in the big container, the milkman number A is pouring the milk over here. Like him, there will be some other milkman will also be available. Okay, there is some other milkman. Okay, so like that, we call the milkman as milkman number B or milkman number C. So they are also pouring the milk to the society, either by pouring or by getting the milk. That depends upon the requirements. Okay, so like this. So where we can able to see in the society, okay, if the society is getting the milk from only one milkman, there is no problem. Okay, so now the society is delivering to the customers. Okay, so let us say the customers C1, C2, C3, and C4 and C5. Okay, so let us say that the customer C2 is saying to the society that the milk what I purchased from your society, it was not pure. Okay, so the milk what I obtained from your society, it was not pure. Okay, so what the milk you are selling, you are giving some impure milk. Like that, if either one customer or all the customers are saying means, the society cannot able to blame either A or B or C, because each and every one are milkmen. They are coming to the society and they are pouring the milk to the society, and the society is distributing the milk. So there is no other go. So now what will happen to the society? Okay, they will be having some confusion. Which milkman? So at the every end of the society, at the entrance of the society, what they will do, before the milkman is pouring a milk, they will check the purity of the milk. So once it passes the purity, then only the society will receive the milk. Okay, then only the society will receive the milk. So by that we can, if the milk is not passing the quality check, the society will return the milk to the particular milkman. So this is the normal, typical work of milkman even now. You take any village, whatever the village you take, this is the thing. This is an example for a microgrid. Okay, this is an example for a microgrid. How I'm telling us a microgrid means, let us say I'm going to take some other ink, so let us take a black. Okay, so let us say that, so here this is a conductor. Let us say that the milkman is serving as a conductor. Okay, so what I can able to say that, that is I can able to take the ink color of black. So let us say that two cows are, one is called as my solar, okay, and another one is called as my wind. Okay, so these two power plants, okay, so they can able to meet generating the power of 20 kilowatts. Let us say that's a 20 kilowatts. Okay, so I'm having the 5 customers. Each customer is taking the 4 kilowatts as their demand. Okay, 4 kilowatts as their demand for either from the industrial customer or residential customer, or else critical care customers. So they are having this. So 20 kilowatt generation. So I'm giving to all the customers. Okay, so now we can able to understand here what the thing we are speaking as a milk. Here the milk is called as my current. Let us say that current I. Okay, or as a power. So it is been, let us say that the kilowatt means it is called as a power. So the power I'm going to deliver to the individual customers. Okay, so this is called as a microgrid. Okay, so here also what is happening, if any one customer is saying that I'm going to my native, so I don't want to waste this 4 kilowatt. So what I'm going to do, I'm going to give to the society. Here the society is called as my grid. Okay, here my society is called as my grid. What the function of the grid? The grid is receiving the power from the generating station and then distributes the power to the customers. Okay, either it's the customers or else those who require power, those who are in the demand. This is called demand side management. Okay, that is what is the excess power you are generating that has been given to the grid. For an example, as per the milkman example, we can able to see that is if one power that is called as the house number 4 is saying that I need some extra power of 6 kilowatt. So I'm having the 10 kilowatt of power required. So what I'm going to do, from the grid, I'm going to get the power. Okay, so this is called the grid connected system. And also, as I already mentioned you, before you are giving to the milk to the society, I want to check the purity of the milk. So here also, we are going to check the purity of the electric power. So this checking point is called as the PCC. In the power systems, we call it as a PCC. What is meant by PCC? PCC means point of common coupling. See, whenever you want to measure THD or harmonics, okay, THD level or TDD level or whatever it may be, or any power quality, you should not measure the power quality at anywhere else. You have to measure the power quality only over here. Because as a milkman, I will say to my house that what the milk I'm giving is pure only. Even though the milk is impure, what is the role of a milkman? He will say what the milk I have given as pure only. Okay, but the checking point is available only at the society, because like this milkman or like this microgrid, there will be some other power generation station is also coming. Okay, like some other power generating station will also come in different village. So when all the people are giving the power at the same point, that point is called as the grid. So a grid is a point where all the generating stations will meet. Okay, so at this particular meeting point, before I'm delivering the power to the grid meeting point, I want to check the power. That checkpoint is called as the point of common coupling. So normally we have to measure the THD only at the point of common coupling. So what is the problem available in the microgrid? Okay, so the problem available in the microgrid means, let us say about the milkman story. So in this milkman story, we can able to understand, so let us say this milkman is working for as a milkman for about 10 years. Let us say about the 10 years. Okay, I'm going to ask him a question. So how much of power you have delivered in 15 June or July 2010? Okay, how much of power you have delivered to this particular thing means the milkman does not know this data. Because every month he will collect the information, and he will give the note, he will write the note, and every year he will be throwing the particular thing. Okay, if we ask about the milkman, he can able to see that, say what is the accounts for the past year, what is the accounts for the previous month, what is the accounts for the previous day. Only those accounts he will be maintaining. If you go and ask the milkman about what is the history of 15/7/2010 for house number 2, he cannot able to remember, because no milkman is having a computer database or computer system and how much of power being delivered like that. So he's not having that kind of information. So without this information, what is the problem means, this milkman is depending upon only these two cow number 1 and cow number 2. Okay. For an example, if the cow number 1 is not feeling well, or else the cow number 1 is died, what will happen? He has to work with only 10 liters of milk, and he cannot be able to meet the demand of the remaining houses. And the second one, if both the cows are not available, means we cannot be able to imagine the life of a milkman, because his life is completely depending upon these peoples. Similarly, whenever we speak about the microgrid, whenever there is no power in the solar, we have to meet the demand only with the wind energy. Let us say that if the solar and wind, it is not giving the adequate power, we cannot be able to create a microgrid. So we need to ensure whether the power generation from our end by either solar and wind are appropriate to meet the demand. Okay. So how, without the data, we cannot be able to do this task. So that is the reason we are making a smart grid. What is going to be smart grid? Smart grid means it is a data enabled microgrid is called smart grid. Okay. So now I'll explain you what is going to be a smart grid. So here we can able to see the milkman story. Okay, that is, he is having the meeting the demands, and he is giving to the distribution, and he is distributing the milk, and then he is giving to the grid, and we have seen what is going to be grid and everything. Okay, so now the same milkman story, what we are going to do, we are going to connect the sensors in the milkman. We are going to connect the sensors in the 2 cows. We are going to connect the sensors in all the 5 houses. Okay, we are going to connect the sensors from the society. We are going to connect the sensors in the checking point. So each and every day, for an example, today, let us say that 19/11/2021. Today, okay, so what is the power, what is the milk given to the H1, what is the milk to the H2, what is the milk to the H3, H4 and H5, how much of milk is given to the society, how much of milk is received from the society. By this information, you can able to get. Similarly, the next day, 20/11/2021, so you will collect the same information like this. Okay, so in a particular year, you can able to get a graphical representation for each and every house. So for an example, let us say that I'm going to draw the house H1 graphical information about the milk receiving. You can able to see that, let us say that they are receiving the 4 liters of milk. Okay, so he is receiving the 4 liters, and sometimes they are not, they are receiving only 2 liters, and then some days they are receiving the 0 liters, and sometimes they receive the 10 liters of milk. So for H1 house 1, I can get the information that, in these areas they are not receiving, they are receiving 0. That is, this particular duration, they are not receiving my input. Similarly, for the H2, the house 2, for the particular complete year, I can able to get the graph like this. Okay, that is, in this year they are getting, for a long period they are not getting my milk. So by this, I can able to get some information. So this information will be helpful for the milkman to decide whether he has to continue with only 2 cows. If the demand is more, he can able to include 1 more cow, or he can able to include 2 more cows. Okay, so only with help of, so for prediction and forecasting, data is very, very required. As far as renewable energy, the prediction analysis and the data is very, very important. Why it is important, So let me assume that, it is not assumption, it is a reality. When India got independence in 1947, okay, so we are having only about 1,367 megawatts of power installed generation capacity in India is only 1,367. Now let us see that, we have crossed about some more than 75 years or 78 years. We are reaching the 2021. We know that, that is about 3 lakh, some 70,000 megawatt is available at now. So we can able to understand, between the 1947 to 2021, we took nearly about 78 years or 77 years between the independence to this 2021. We have increased only about some, like we can even able to understand about 4 lakh megawatt, nearly 4 lakh megawatt only. But as per the requirement of 2021, we need at least around 9 lakh megawatt. At least around 9 lakh megawatt. You can able to see the difference between the 4 lakh and the 9 lakh. We can able to see there is a depreciation of 5 lakh megawatt is not available with us. So our we are taking so much of measures in order to increase the installed power generation capacity. But one fact we have to understand, from our Indian independence to the present year, okay, more than 78 years, so we have taken around we have increased only 4 lakh. Okay, 4 lakh megawatt has been increased to only 75 plus years. Okay, 4 lakh megawatt. But at present 2021, we need at least 9 lakh megawatt. So 5 lakh megawatt is not available at present. Okay, so we are having some plans to increase. How we can able to increase? You can able to see that 4 lakh has been reached only after crossing 75 years plus years. Okay, so we need to work up around at least around 25 or 30 years in order to reach the 9 lakh megawatt. So if you're going towards the 25 or 30 years in 2050, let us say that at that time our demand will be increasing only. Okay, let us say that at that time our demand will be more than 15 lakh megawatt. Okay, at that time only we would have reached at least around 9 lakh megawatt. So the demand is keep on increasing. So since we are now having forecasting only on the microgrid as like a milkman story, we are not forecasting the proper integration of the renewable energy. What is the renewable energy is required? How we can able to meet the people's requirement of the renewable energy? That particular forecasting can be obtained only with the data science. That is the role of a data. So data is not only responsibility of a computer science engineering or the information technology. It is a very big thrusting area for our electrical and electronics engineering, especially for those people who are doing the research in renewable energy or power electronics or power system. So this data science is very, very important because for forecasting. So if the forecasting has been made, let us say that if the forecasting has been made in 1960s, yes, they made some forecast in 1960s. Only based upon that only, during 1960 and the 1970, so much of power plants have been constructed. Okay, after this 1970 or 1980 or 2000 or 2010 or 2020, have you received any information about the starting of new power plant? No. Why? The reason is for starting a new power plant, to construct a new power plant, minimum it requires some 15 plus years, for the complete construction and installation and commissioning. And also we have to invest about nearly about 20 lakh thousand of money. Okay, so can able to understand how much of money we have to investment, and also political influences, and also some changes, policy changes we have. So that is the reason at present we are not even hearing any one of the typical starting of a power plant. So our demand is high, but the generation is very less. We took 75 plus years only to increase 4 lakh megawatt, but at least minimum we require 9 lakh megawatt. So for that purpose only, we have to make use of the various data science tools. So now we are going to see about, I was saying some story about microgrid and the smart grid. Now we are moving on to our presentation. So this is the components of a microgrid. As I already mentioned you, okay. So as I already mentioned you, as like our microgrid, it's a milkman story. So same thing. You can able to understand about the various tasks, that is we are having some generating stations like wind turbine, and also gensets on the PV, and also energy storage, and also micro turbines. We are having the energy generation things. So we can able to understand the major components of the microgrid is, the first one is the distributed generation. That is the generation you are not depending upon one person, you are having the collectively more number of person. So that is called as a distributed generation. That is, the generation is widely distributed. Okay, so then based upon this particular thing, where we can able to see, you have understand about the generation, because we have normally want to make sure that, okay, so where we can able to understand about the distributed generation. Next one is the standard loads. Let us say that the loads may be your industrial user, commercial user, or a residential user. And the third one is the storage devices. Let us take the storage maybe of a battery or a flywheel or else a capacitor or any other medium to store the energy. Okay, and the next one is called as a control system. Okay, so here we can able to see the control system is basically the operation of the switches. Okay, switch means that is the point. So whenever you want, so this switch is normally open. That is, you are not sending the power to the grid. So for an example, if you want to receive the power or if you want to send the power to the grid, that is a utility grid, you have to control this switch. How the switch can be controlled? By measuring the demand or measuring the requirement from this end. So based upon the measuring and measuring the requirement or measuring the demand from this particular end, we can turn on and turn off the switch. So the point at which we are going to communicate this grid is called as a point of common coupling. So in this point only, we have to measure the THD or any power quality we have to measure only at this particular point. Okay, so just you are measuring the power quality at this particular point. Let us assume that you are measuring while giving to the load, you are measuring the power quality means it's a standard THD value. But normally in a grid connected system, the power quality or THD, we have to measure exclusively only this particular point. And these are some of the challenges at present, So the challenges, because when I was started this work in 2010, the early 2010, I started this work basically on the micro grid arrangement. So here I can able to see that, so here in this micro grid work, at that time it was just emerging. Now it was having the many people have started to work and many people are doing the research in this particular area. So we can able to understand that how we can able to get this particular thing. So here we can able to get along this different challenges. Okay. So here this power quality. Okay. So as I already mentioned you that we want to keep power quality means we want to keep the voltage in acceptable limits. What is meant by a power quality? Power quality means that is called any deviation in your voltage or frequency or current that makes the mal-operation of your devices. That is called as the power quality. So here we can able to see that, so I have to measure the voltage and the frequency and also the phase difference. Let us say a three-phase grid. I want to see the phase difference. That means, let us say that R, it has to start by 0 and Y, it has to start by 120 and B, it has to start by 240. But because of the imbalance, what will happen? So there will be the phase difference will not be appropriate. Okay. So in this disappropriation, I cannot be able to connect my system to the grid. Okay. So I want to see that particular thing. So this power quality work I have done for my PhD. So my PhD work is completely based on power quality. And after this PhD, I worked for the synchronization. What is meant by synchronization? Synchronization means, for an example, if a person is available whose frequency is 50 Hertz, he will be matching only to the frequency of 50 Hertz. So matching of the frequency is called synchronization. I want to synchronize it. How we can able to synchronize? With the help of power electronic converters. So with the help of power electronic converters, we can able to work with the synchronization. That is, always you can able to make the frequency to be 50 Hertz. Always we can able to ensuring the appropriate requirement of the grid is called synchronization. I want to ensure this. Because, most of the times we can able to understand that the frequency may not be appropriate. I want to make the frequency to be appropriate. How to make the frequency to be appropriate? With the help of power electronic converters. How to make with the help of the power electronic converters? With the help of the appropriate switching angles. How to make the appropriate switching angles? By optimal pulse width modulation techniques. How to make the optimal pulse width modulation techniques? By proper generation of the signals. How to generate signals with the help of the normal amplifier circuits. Like that, So our way of this synchronization will start from the subjects what we have studied from the second year onwards. Okay. So from the second year onwards, we have studied the subject like analog electronics. From that, we have studied about the amplifier, multivibrator, split trigger, and then we traveled our journey with the power electronic converters that's called as the power diodes and the power transistors. Okay. So the second year, what the students are studying is called as the signal switches. The devices are called as the signal devices. The third year, they will be studying about the power electronics. That is called as the power devices. There is some construction wise, there are some differences between the signal diodes or signal devices with the power diodes or power devices. So the synchronization, the matching the three quantities, the voltage or frequency and as the phase angle. So this synchronization work I've done after my PhD. After my PhD, I worked with the synchronization and this paper is also published in IEEE. And then in my postdoc, I worked for the production purpose. Okay, we can able to understand there will be some fault will occur in the power. There will be fault will be in the solar. There will be fault will be in the storage. There will be fault in the solar power, or there's a fault will be in the batteries like that. So here my data analytics system will show where the fault is located. Okay, so like IoT based fault detection system, so I'm having my own system. It was completely developed in the hardware. So this work also published in IEEE transactions. Okay, so in 2018 my paper was published in the IEEE transactions on protection of this microgrid. So more number of challenges. What are the challenges I listed down? So these challenges I worked with and they were published in the IEEE. All the three, power quality also in IEEE, synchronization is also IEEE, and production is also in the IEEE. So when we speak about the grid, microgrid with the grid interaction, so there is a recommended by the IEEE standard of 1547. So whenever we are having the fault in the grid, okay, so whenever the fault in the grid, so I want to isolate the grid. Okay, so we can able to understand that that particular situation is called islanding. Islanding means there is a separation. Okay, so we can able to have some relays and production devices in order to meet this particular thing. So this microgrid is classified into two types. One is called as the AC microgrid, and another one is called as a DC microgrid. Nowadays, many people are using only DC microgrid because many people are interested to work with the solar, and also from the wind we are getting DC. At present, with the help of a DC generator, we are getting the DC power from the wind as well. And then many people are working with the fuel cell. So all these things are giving the DC power. So we are having this input DC. So whenever we are working with the DC microgrids, we can able to see inverter is necessary. So for an example, the AC microgrids, a transformer is necessary, a disconnect switch is necessary. So out of 100% of people, nearly 95% of people are working with the DC microgrids. Okay, because of the what else to say? Because of the availability of the solar and the wind. Okay, AC microgrids means the people will be working with the AC winds and also some AC power sources. Okay, where the transformer, the switch is necessary. The DC microgrids inverter is necessary because the DC microgrids obviously are using the energy storage system. So this is a schematic of the microgrids. What I have developed in US. This is called as a solar microgrid, and this is the wind microgrid. Let us explain what is the building block of the grid integration of my solar. Okay, so here we can able to understand from the solar PV, I'm getting the DC power. So that particular DC power, this is the charge controller. I want to give to this charge controller. So this charge controller it is a device which is used to prevent the battery from overcharging and over discharging. It's a protection device for battery because I should not allow the battery to charge maximum. I should not allow the battery to discharge maximum. So I want to prevent the battery from overcharging and over discharging. So it is a control device. What control it will do? It will control the charge. What charge? The charge available in the battery. That is the reason it has got the name as charge controller. It is not a solar controller. It is called as a charge controller. It will control the charges available in the battery. So here it is connected to the battery. Now you know that this charge controller will have the 6 terminals. Okay, it's totally 6 terminals. So these 2 terminals I will be given to the input. That's called solar, and these 2 terminals I have to give to the battery, and these 2 terminals is called as a dummy terminals. Okay, or else I can able to give to the DC load terminals, and this is called as a AC load terminals. So we can able to see from the charge controller another terminal. I'm going to take to this particular thing, and I'm going to give from the battery. I'm going to connect it to the inverter. Okay, so this inverter will be acting as a bidirectional inverter. That is, so we can able to understand from the battery. I'm taking the DC. The DC is converted to AC. I'm going to give to the grid. Okay, so this is the normal flow of inverter system. But for the grid connected systems, we also want to understand that my direction to be bidirectional. That is, from the battery, I want to connect this inverter to convert my DC to AC, and then AC is given to the grid. For an example, I want some demand. So when the demand is more, I want to get the power from the grid. Okay, power from the grid means I'm getting the AC power from the grid. So now the inverter should act as a rectifier. So when the direction is reversed, this inverter should act as a rectifier, and then it converts the AC power from the grid to DC, and that DC I can able to store in the battery. So I want to design a power electronic converter which will be working as an inverter in the forward direction, which can be working as a rectifier in the reverse direction. How to work with? So whenever you are working with alpha value from 0 to 90 degree of a switching angle, it will be working as a rectifier. And the meanwhile, if it is greater than 90 degrees, it will be working as an inverter. So based upon this commanding switching, so that will be governed by the control system. Okay. So with the help of the demand sharing, with the help of the demand management, it will make the things. So it is very easy to talk, it is very easy to explain, but the meanwhile, it is quite difficult in real-time implementation. Okay. So how we can able to make the real-time implementation of these systems? So real-time implementation system requires a lots and lots of things. Okay. So where we can able to what we can able to make sure that particular case. Okay, so where we can able to understand that whenever we have to make the particular thing, we have to understand the case and case by case differences to be ensured. Okay, so we are ensuring that how we can able to make along this particular thing. Okay, so where we can able to get this microgrid. Okay, so this is the normal typical working of a microgrid. So here we are not collecting the data, just we are sending the power from the grid and receiving the power from the grid. So this is the thing what we can able to understand for the solar based grid connection. In the wind based grid connection, let us say that we're having a separate AC bus. Let us say that the wind interface, let's assume that the wind is generating the AC power and we're having the AC interface. So I want to convert the AC to DC converter, and then we can able to see that either I can able to use a normal wind turbine, or else I can able to make use of able to make use of a wind simulator, and then this DC will be stored in the help of a super capacitor, and then it is given to the charge controller, and then it is given to the DC bus. From the DC bus, I'm taking to the inverter, and from the inverter, I'm going to connecting to the grid. Okay, so this is called as a hybrid inverter. Hybrid, okay, hybrid means performs more than one action. Okay, so during the forward mode, it will act as an inverter. During the reverse mode, it has to act as a rectifier by controlling the proper switching angles. Okay, so this is the typical thing for the solar and as well as the wind. Renewable energy integration into the micro grid. And next one, let us see about what is happening to the hybrid condition. So in the hybrid condition, we are able to see I want to create a separate AC bus that will be associated with my main grid, and a separate DC bus that will be associated with my charge segments. Okay, let us say about like a solar, what the diagram as I said already. So solar PV inverter and then a charge controller, and is given to the DC bus. Similarly, a hydro system or a wind energy conversion system. So I want to maintain a separate bus related to the AC bus near to the grid and a DC bus near to the charging environment. So this is the microgrid what we have established in Northeastern University. So similarly, the same microgrid is also available in Congo Engineering College. I have established. Okay, so if you want to take any readings, or if you want to visit, or if you want to see how the signal conversion takes place, you can always, I invite you. You can able to visit. Okay, so and this idea I got during my postdoc level. So here we can able to see this is a control terminal. I will show the block diagram, and then I will show this experimental setup. So the block diagram, this is the block diagram, So where we can able to understand, this is a solar PV input. From the solar PV input, I'm going to connect it to the charge controller, the input under the charge controller. From the charge controller, I'm connecting to the battery segment. Okay. So from this battery, what I'm going to do, I'm going to collect the information of the battery. So this is called as the battery gauge. Battery gauge means it will establish the condition of the battery. Okay, so it will show whether the battery is charging or whether the battery is discharging. So we can able to understand we are using this Ethernet cable to collect the data. These are the Ethernet cables. Okay, so what we are saying, this is an Ethernet cable we are going to connect to collect the data, and this is called as a current shunt elements. That is called as a switch, opening and the closing of switch. Okay, so a current shunt element is normally called as a switch. We can able to see the three different controls. This is a control action number 1, control action number 2, control action number 3. Okay. So from the battery, what I'm going to do, I'm connected to the inverter. From the inverter, I'm going to connect it to the grid. Let us say that is a genset, or also let us assume it is a grid. Okay, so what we can able to say that, from this particular building block, so here I can able to collect through the hub of the parameters of the battery. So this parameter of the battery is connected to the port, and then finally here I'm using a computer to collect the data, to store the data, and finally I can able to make a control to the genset, okay, whether what the power to be given to the grid to establish decision making. So here I can able to connect a DC load or AC load. The same way I can able to show this particular diagram. So here is a charge controller. From the charge controller is connected to the two batteries. So from the battery, okay, it has been connected to this is called as a bidirectional inverter, and this is called as a 3 current shunt elements. Okay, we can able to see here one, and here 3 current shunt elements to make 3 control actions. Okay, obviously there are 4 control actions, but I have worked with 3 control actions. What are the 3 control actions? So the first control action is a normal thing, standalone. The second control action is I want to connect it to the grid with the battery, and then connecting to the grid without battery, and then how we are going to make a proper standalone function. So for this complete microgrid setup, I'm not taking a charge controller as a reference. I'm not taking the inverter as a reference, because when the power supply is there, the charge controller will function. When I'm directing the power supply, the inverter will work. So I can able to measure the load. So the only person who is taken as a reference for my work is this battery. So this battery, we can able to understand. Normally the people will say about that battery means it will come across 2 control functions. One is called charging, one is called discharging. But I will tell you, in discharging means not an issue, because depending upon the load, your discharge cycle will be different. For an example, let us say that how the discharge cycle will be different. So for an example, if the battery to be discharged, let us say that I'm taking the 7 amps load means, your discharge cycle will be like this. Okay. If you're having some 15 amps means, the discharge cycle like this. So discharge cycle is normal. My concentration is only on the charging cycle. So when the battery will be get charged only when I'm giving the power supply from the solar PV panel connected to the battery. Okay, so I need to understand that this just measuring the charging voltage alone, I should not take the decision. So this charging cycle will be classified into 3 stages. This is not only for the solar PV system, even for your mobile phones. Okay, so I will explain what is a typical cyclic difference in your mobile phones. Okay, so if you have any queries, you can put in the chat box, and every now and then I'm visiting the class, so to see if you have any queries in between at the middle. If you can able to put. So that's what the reason I'm switching over from the presentation and returning back to the class. Okay, so at present I can able to see there is no queries. Okay, if you have, you please make it. Okay, so here we can able to understand. Even let us say your mobile phone. So let us say that you are going to charge your mobile phone from 5%. Okay, so 5%. So for an example, let us say that from 5% to, let us say, about the 70%, you can able to see the time taken for your charging is very fast. Okay, and let us say that from 70% to the 90%, the time taken from your for your battery to charge, it is quite reduced. Let us say that when your battery is going to charge from 90 to 100%, the time taken is very, very less. Why it is happening means because the battery consisting of 3 charging cycles. Okay, so the first cycle is called as bulk power flow. Second is called as the absorption. Third is called as a float. So I need to measure the individual values of the battery. So I want to measure I want to measure whether my battery is in the bulk stage. So whenever you are purchasing a battery, or else if you Google out the data sheet of a battery, you can able to see what is your bulk voltage. Bulk voltage means throughout this particular voltage, you can able to get the fast charging mechanism. And you can able to see what is your absorption voltage and what is your float voltage. So by this, you can able to understand whenever the voltage is available in the bulk range, your charging will be maximum. Whenever it is in the absorption range, your charging speed will be quite less. Whenever the voltage is reaching to the float stage, so we can able to understand that the charging will take much more time. So based upon this principle only, many people are working with the electric vehicle technology to increase the charging time. how to increase the charging time without knowing the concept of charging, because charging will be takes place in the 3 different phases or 3 stages. Okay, so let me take, if it is having some 3 different stages, so these 3 stages we have to understand step by step. Okay, so that is the reason what we have to keep in our mind about this particular factor, how this charging takes place. Okay, so now with the help of a graphical structure, I will show you how the charging takes place. See, this is a charging cycle of a typical 12-volt battery. Let us take a 12-volt battery. So as I already mentioned you, this is a phasor diagram for your voltage, and this is the phasor diagram for your current, and the x-axis is going to be your time taken. Okay, so this is the time taken for your bulk stage. So this differs from battery to battery. Let us say that, the bulk stage time taken, this is your absorption stage, and let us say that this is a time taken for your float stage. So now we can able to understand that how these 3 stages are working in unison. What is happening during the bulk stage? So in the bulk stage, even though your battery is about 12 volts, during the bulk voltage, that is when the battery is about to get charging, so this 12 volt will increases and it will reaches to the level of 14 to 14.6. Okay, so this will be normally specified in your data sheet. So whenever you are designing an inverter, whenever you are going to design an inverter or a power electronic DC-DC converter, we have to understand that what is the bulk voltage, because normally we start the design with only a 12 volt network. Okay, 12 volt means based upon that we will measure the average value and the RMS value, and then you can able to find that what is the voltage you have to get before you are subject to the grid environment. But here, what I'm going to do, so let us say that I'm going to give a 12 volt. So during the bulk stage, it is reaching towards the 14 to or even a 15 volt. Normally, my voltage of a battery is just a 12 volt, but it reaches to the maximum amount of voltage. Okay. Similarly, my current drawing is also very high. So this is the time where my mobile phone is also charging very fast, because the battery is drawing maximum current. So maximum current means, the load is drawing maximum current, so my efficiency will be more. So the time taken to charge my battery at the initial stage is also very high. Okay. And next one, what is happening in the absorption stage? So in the absorption stage, the voltage will become steady state. Okay. So usually this absorption for a normal 12 volt battery, the battery will be in the absorption, even it will take for an hour. Okay. So at that time, we can able to see in the absorption stage, the current is dropping down. Okay, so it is tap absorbed, but even though the battery is charging, okay, so actually our battery charging maximum will be takes place only in the bulk stage. In the absorption stage, I can able to see the current is dropping down. Okay, and let me say that what is happening in the float stage. So in the float stage, the 12 volt battery, which is reaches to the 14.6 volt level, it reduces to the level of 13.4 to 13.7 volt. And let us say that, the battery will draw a very small current. It will draw a very small current, and then the next cycle will start. Next charging cycle will start. So the number of charging cycle means, so if you purchase a battery, so they will show that, your battery will come across 5,000 charging cycles. So this is that particular charging cycles. So in a lifetime of, that is the reason many people, battery manufacturers or battery distributors, they are giving the battery for only 5 years warranty or 3 years warranty. Okay, either a 5 years warranty or a 3 years warranty. So so where we can able to understand that how we can able to get this particular thing. Okay, so this is the way how we can able to get the various to get the hard time of the networks. Okay, so if a battery covers the 5,000 charging cycles, means the battery will be completing its life. So the lifetime of a battery will be a 5,000 cycles, 5,000 charging cycles. Okay, so this is the charging cycle. So we have, so whenever working as a microgrid, we have to take the bulk voltage as a reference, absorption voltage as a reference, floating voltage as a reference, in order to ensure that for taking a decision, what decision we have to take, whether you have to send the power to grid or not. Okay, so based upon that, for the given microgrid, we are working with the 3 different modes. Initially, it will be in the mode 0. Okay, so we can able to understand the charge controllers turn off. So it was not a ideal operation, mode 0. So the mode number one, it is called as a standalone mode. What is standalone mode? So without connecting to the grid. This is called as the half grid systems. It's not on grid. Okay. So we are going to ensure that the MPPT charge controller is enabled. So normally many people are working with the MPPT. So now this charge controller is at present coming in the market. It enables with the MPPT. Okay. So it is called as a MPPT enabled charge controller. So I am enabling the charge controller with the grid support. So we can able to understand. So here we are going to take the battery of 14 volt, because in US we are working with a 14 volt battery. So normally it comes around 28. So along with this design specification, the absolute voltage of a battery is taken as a 28.8 volt. So based upon the data sheet, the float voltage is 27.6 and the charging point limit is exactly near approximately 1200 watts, and the bulk voltage is equal to 24 volt. So I say that what is a bulk voltage, what is absorption voltage, and the float voltage. So this we have to set point. These are the set points. Okay. So now what the controller, the charge controller will do, so it will collect the status of the battery. It will collect the status of the battery. That is whether the battery is full or not. Whether the battery is full or not. Okay. So because in our grid-based work, as far as I'm telling about, because in the grid-based work, we are not that much of using the battery, because we are straight away connected to the battery. But for the real research on the real control system, we need to use the battery. So where this particular battery will be taken as a reference point. Okay, because I cannot take the inverter output voltage as a reference, because you can able to control the inverter output voltage with the help of your PWM. So my PWM may ensure or may not ensure what is the control of the voltage obtained across the output gate. So I cannot able to take the inverter as a reference. I cannot able to take a solar PV as a reference, because I cannot able to give any kind of feedback. So here we can able to understand the battery is the only terminal for a microgrid work, where we can able to see that whether the power is coming from the solar PV or the power is diverted to the grid or not. So based upon the decision can be made only by collecting the status of the battery at every intervals of time. So when the battery voltage is less than 25 volt, okay, so the input voltage is present, and it will enable the charge controller to charge the battery. This because we can able to understand that that is various cases we can able to get that particular point. Okay, so this is the thing. So at the same time, so the local AC output will be from the AC input. So that is the normal operation. So we are going to fix a point, that is whenever even the battery voltage is 28.8 volt absolute, we are fixing the voltage as 24. So whenever the voltage is lesser than 24, I need to enable the charge controller to charge the battery. So the charge controller is giving the command to the battery. So that because we know that the charge controller is a device which is used to control the battery or prevent the battery from overcharging to over discharging. So my commands will be given to charge controller, and the charge controller will communicate to the battery whether to charge or not. Okay, so that kind of thing is available in standalone mode, but we are interested towards only the grid tied mode. Okay, so the mode 2 speaks about the grid tie mode with the battery bank. So here also we are going to configure a setup that same thing. The MPPT charge controller is enabled, the same thing. So we can able to understand the inverter with the grid tie is also enabled, and we can able to see that the absorption voltage and absorption time and the floating time is set to 0. What is absorption and the floating time? As I already mentioned you, this is called as this time is kept as 0, and this time is kept as 0. Okay, the settings point. Okay, and then we can able to understand the selling voltage. There is absolute voltage set as 28 volt. Okay, so the battery will be charged. So whenever it reaches towards the particular value, so in this mode, whenever the battery is reaching the 28 volt, that is an absolute voltage. Okay, what is happening? The solar PV module will start to sell the power. Okay, so we are going to set the absorption as 28.5, float voltage as 28.3, and bulk voltage is 28.2. Okay, so these voltages we are going to set. So based upon that, it will take the appropriate transformation from the bulk to float to absorption. So the time taken to charging very fast, it will be accomplished only by setting these limits. If we are not setting the bulk or absorption or the float, it is quite not proper. It's not possible. So how to set this limits means, so we are going to write a program. And normally when I was in US, we wrote the program in Visual Basic. Actually, comes under the Visual Basic. This was a previous model of microgrid. So now we are having the sophisticated IoT based systems where you can able to communicate with your keyboard. Okay, so in the system, what I worked with basically on the Visual Basic. Okay, so what the command, we have to set the voltage with our Visual Basic command. So that command will be a bidirectional, and that command will be given to the charge controller to communicate to the battery. Okay, so we can able to understand now the charger will be working in the bulk mode, because the most of the time when the battery reaches the 28 volt, okay, so it will be starts selling. So we have to ensure that the battery terminal voltage should be less than 28.2 volt while selling it. Okay, so the selling voltage means, what does mean selling? Selling means giving the power to the grid. So this is called as a standalone mode, because normally standalone mode means now most of the researchers, what they are doing, they are connecting the battery. Sorry, they are connecting the solar PV panel, and then connecting the solar PV panel, and then they are connecting to the DC-DC converter, and then we can able to understand about, they will be communicating about the various case. Okay, so where we can able to understand about the concepts, so that is, they will be connecting one by one. So that is the point. And the next one will be the grid tie without battery. So the solar PV, the integration to the grid, they can operate in 3 different modes. So with the help of this particular representation, or with the help of this particular thing, we can explain how the standalone mode works. So standalone mode means, how the people normally will say, connect the solar PV, connect a DC-DC converter, connect a battery, connect an inverter, connect to the load. That is standalone. No, it is standalone only. But where is the control? So control means how you can be able to ensure that the battery is completely charged. How you are going to prevent the battery? So we have to follow these procedures by fixing the bulk, by fixing the absorption, by fixing the timing environments. And the second one we have seen about with the battery bank. And the last one is going to be the grid tie without the battery. Okay, so here we are going to enable the MPPT charge controller, and here also the absorption time and the set time is equal to 0. So here the set voltage is fixed as 25. So earlier we have set as a 28 for the battery bank, because here we are working with a battery. What's the total voltage of a battery? 14 voltage of a battery, 14 plus 14, 28 volt. So 2 battery. So that is my system. So I'm using a 2 voltage of 14 volt. So 2 battery, so 28 volt. So I'm fixing when the battery is connected. But here, since there is no batteries available, I am fixing the voltage what has been receiving at the input terminals. It is going to be at 25. Okay. So now we can able to understand, even there is no without the battery, my controller will monitor whether the battery is charging or discharging. Okay. So we can able to regulate the voltage, and we can able to control the charging current. Okay. So we can, when the battery is having the charging current, so here we are going to establish the reference of the current, not voltage. Okay, so we can able to understand, we are going to measure the current. When the battery is having a charging current, it will reduce the cell voltage. What is the cell voltage? Cell voltage means what is the voltage you are delivering to the grid. That is called cell voltage. You are selling the voltage. So that is called cell voltage. So when the charging current is when there is a discharging current, I want to increase the cell voltage. Okay, so we can able to understand the MPPT will be in the bulk charge mode. So this is the way how we can able to control a microgrid. Okay, you just correlate the story with the milkman story. You just correlate the story with the milkman story. Okay, so let us say that in a standalone mode, the milkman is not giving to the society. So the milkman is not giving to the society. So even though you put the 20 liters of milk, he is fixing the set point. And he is collecting the status of his milk can at every intervals of time. And at the same time, for the society, the normal people, those who are giving the milk, or the normal milk what is coming to the society, is coming to the society. The society is not damaged, our society is not interrupted. So at the same time, the society is working well. The local AC output will be from the input, but the milkman is fixing the status. Okay, so whenever the milk can is lesser than the 20, means he has to get the milk. So he's fixing the point in the standalone mode with connecting to the grid. Let us assume that the same milkman is going to, for the grid environment, with the battery bank. Battery bank means the milkman is having some storage element like a milk can. Okay, so what he will do, he will fix the two stages like absorption stage and the floating stage as equal to 0. He is working only with the bulk stage mode, so we can able to understand, so whenever he fixing the point as 28 volt in this particular thing, and then he is fixing that at what level we have to go for the rebulk, at what time he has to go for the cell voltage, so we can able to understand about the grid tie with battery bank. And finally, without battery bank, so is ensuring, is measuring only the current value. So whenever there is a charging current, okay, whenever there is an incoming, so you will reduce the cell voltage. Whenever there is a discharging current, you will increase the cell voltage. So the celling will be increased and decreased based upon the reference value of a current, battery current. So here we are not using the battery voltage. We are not speaking about the battery voltage. We are speaking about the current. Okay. So with the help of the current reference, we can able to see whether I can able to sell the voltage or not to sell the voltage. So these are the typical 3 modes of a microgrid. So we can able to understand the charge controller. This is a typical discharge cycle. We can able to see that, for the different intervals of time, the cycle life will be called as a number of cycles. How we can able to get these characteristics you can even obtain with your MATLAB for any kind of battery. You can plot the characteristics by indicating the load. This is the connection of a charge controller, which consisting of 6 points. The 2 points is connected to the DC load. It is also called as a dummy point. And the 2 points will be given to the solar PV system. And the next 2 points is connected to the battery. From the battery, you connect to the inverter. From the inverter, you give to the AC appliances. So where we can able to see this was a battery. And then till now, we have seen about the microgrid and how to interconnect or interlink our microgrid to the environment. Now we are moving on to the smart grid. Okay, so how we are going to see the smart grid. Okay, so where we can able to understand about. Okay, so we can able to understand about the various things. Okay. Okay. So we can able to get that, the smart grid, it is highly helpful for the renewable energy integration. So we are going to speak about this renewable energy integration. And also it specifies with the advanced metering infrastructure. We can go with the EV vehicles and the options are available. But we have to know what is meant by a microgrid. There are so many definitions for a smart grid is available. Okay, but all the definitions will have only one literal meaning. What does it mean? This is the understand. That is, it works basically on ICT tools. So normally the people will say, so in the teaching process, you follow the ICT tools as per the NBA requirements. Okay. What is the ICT tools? ICT means information and the communication technology. Okay. So as per the definition of the smart grid from the IEEE, so here we are using the ICT tools. What are the tools? Collecting the sensors. We are using the sensors. Why we are using the sensors? To collect the data. Why we want to collect the data? To take some decisions. Why we want to take the decisions? In order to make the forecasting. So this is the normal overview of a smart grid. In the Wikipedia, we can able to see that the smart grid is having the definition of using a digital technology. That is, we are going to make reduce the cost and also to increase the reliability of the power. Okay, and then based upon the Green Energy Act of Canada, they are giving the definition for the smart grid like monitoring and control. Okay, we can, and the electrical people, we can ask a question, sir. Already we are having a network called SCADA. Why this smart grid? What is the difference between the SCADA and the smart grid? Okay, so SCADA means we can able to understand, we can able to monitor the system. Okay, so it is also a remote area monitoring a power plant, a remote area monitoring a system. What is the typical difference means? Here in the smart grid, okay, the thing is we are using the intelligence. Okay, here the supervisory control the data acquisition. Here the control will be made based upon the logic tables or the ladder diagram. We are making the logic like a PLL or a PLC okay, programmable logic controller. So when it matches the particular ladder, it will take the decision. So it will be based upon the logic only. Logic is different. Here it will think as a humans. That's called smartness, intelligent. So it will take the decision not on the logic. So logic means, let us assume whenever I'm using the logic as 0, 0 means 0, 0, 1 means 1. If this is a logic means, SCADA will work based upon this logic. Smart grid means if there is a 0, 0 is 0 means if the 0 brings some danger to the system, it has the ability to convert the 0 to 1. That means it is not following a logic, it follows the current situation. So based upon the situation, it takes the decision. So I want to give a definition for a small story for smart. I want to see a blank slide. Okay, what is meant by smart? For an example, my son is my son. Okay, so I'm going to take my son. Okay, so the first day I'm going to take my son to a temple. Okay, oh my God. So the writing is not quite facilitated, but anyway, I will manage. Okay, so where I'm going to take him the first day to a temple. Okay, so while going to the temple, I'm giving some inputs to him. Okay, so don't shout. Okay, and then respect the elders. Okay, and you should be with your parents. Okay, so these are the 3 data inputs I'm going to give to my son to how to behave in the temple. Okay, next day, okay, this is the first day happening, and this is the second day happening. I'm going to take my son to a marriage hall. Okay, it's a relative marriage. I'm going to take my son. So while going to the marriage, I'm going to give the inputs to my son. Okay, so whoever the elder comes, you have to respect. Okay, you should not take the belongings of others, and you should be stay with your parents. Okay, like this, a 3 input data I'm giving while going for the marriage hall. The third day, what is happening? I'm going to take my son, okay, to my college, okay, to my college, because my wife is also went on work, so I want to take him to my college. The maid is on leave, so I'm going to take the college. So even the college, I'm giving some information, some data. So you should be with me like that. Suddenly, what is happening? Suddenly, the principal is calling me. Okay, so the principal is calling me. Okay, so I'm asking my son, you please be with my colleagues. Okay, I'll meet my principal and I will come back. I'll meet my principal and I'll come back. But the son is not saying that, no, 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 I want to come with you. I don't know anyone over here. I want to come with you. So while meeting the principal, I'm taking the son along with me, but I have not given any inputs to him. I have not given any inputs to him. Okay, so in front of the principal, I have not given any input because in an urgent, I don't know why he is calling, whether he is calling for any accreditation or whether he is calling for any other research oriented or anything or any information. I don't know anything. So because of this uncertainty, I have not given any information to my son. Okay, so he is coming along with me. I have not given any information. So if my son behaves based upon the inputs what I have given during the temple, based upon the inputs what I have given during the marriage, if he behaves in this particular scenario means that is called as smart. So what is meant by smart means, okay, smart is how you are behaving based upon the situations. So if he be in front of my principal, if he behaves based upon this input, okay, based upon this input, so he is elder to my father, so I want to respect him. So good morning, sir. So in his table, there are so many papers are available. He is not taking any paper. He is not. He is not holding. He is not shouting. Okay. He is not doing anything. Okay. So based upon that, so he is. If he behaves based upon my previous input, means that is called smart. So a smart grid means, I am making my grid synchronization to operate with the 50 hertz. I want the grid to be operate with the 50 hertz the synchronization. Suddenly, because as suddenly the principal calling me, suddenly the frequency is coming as a 45 hertz means what will happen? The system has to stop. Okay, so it should not wait for my logic. It should not wait for my thing. It has to make a decision based upon my earlier data inputs. So if it behaves based upon my earlier data inputs, then it is called as my smart. So that is called as a smart grid. So that is the reason that people are speaking about a smart city. What is meant by smart city? I usually ask the people, okay, give me the definition for smart city. Many people will say that, if a city is clean, it is smart city. No, that is not a definition. We have to collect the data of all the peoples available in the city. So based upon the data, we have to collect some information. For this, I will give you another example, a small story. So, for example, if there is one doctor, okay, there is one eye specialist doctor is available. Okay, so let us assume that he is visited by so many peoples from a particular town. Okay, so he is eye doctor. So many people are visiting. Okay, so patient number 1, 2, 3, 4, 5, they are visiting. The doctor is seeing the eyes and he giving some medical and is going out medical, going out medical. So he completed the consultation for all the 5 patients. If the doctor is maintaining a separate database like that, what is your name, what is your age, and what the food you are taken yesterday, and where are you coming from. If that information he can able to collect, means on that particular day or that particular month, he can, with the help of this data sheet, he can able to understand that the people who belong to the age of 30 to 31, who had the food of some different fish in the yesterday evening, those who are living in the particular place of XYZ, they are affected by this particular disease. They are affected from this particular. So this decision can be arrived only with the help of data, not with the help of a small amount of data. He needs a big data, a collection of so much of data. Then only he can able to arrive to the solution. So if we can able to arrive to the solution, where we can able to understand about the case. So this is the normal, typical thing what we have to remember about the data. So data are useful only to take the decisions or forecasting. And here we go. So this is the simplified block diagram of a smart grid. So normally the smart grid controller, it receives the information from the generating part, and then for the substation, these are called as the input sources. And from the smart grid, we are giving to the output of the office. Okay, and we can able to have the battery and everything as like a micro grid only. We are having this. Okay, as the same block diagram what we have seen to the microgrid, the same block diagram for the smart grid. The only thing is that it works on the data. It works with basically the data environment to take the appropriate decisions. What are the benefits of smart grid? So this is the work what I'm presently doing on self-healing. So self-healing means if there is any problem available in the grid, okay, so for an example, it will not wait for the people, or it will not wait for the engineer, or it will not wait for others to operate it, or it will not wait for others to connect the particular thing. Okay, so if it heals by of its own, that is called self-healing. And also it will be interacted to the consumers and the markets. Okay, how to explain this? Let me come back to my blank slide. Okay, so where I can able to show. Okay, so the interactive means, for an example, in our house, we are paying the money for each and every unit. Okay, so one unit is equal to 1000 watt hour. That is called the unit. So we are purchasing our electrical loads by power, and we are paying the energy bill by energy. So that is called as an energy meter. So energy is equal to power multiplied by time. That is how much of power you are consuming for the specified time is called energy. So that is the reason energy is given by watt into hour. So for one unit, we are paying some money. It depends upon your place in which you live. You will be paying for 2 rupees or 1.75, or the suburban area 1.25. That is also we are having a slab of up to 500 units. You will pay 1.5. When the greater than 500 units, you will pay. So that is the thing what we normally give for the payment for each and everything. But whether we ensure that, let us say that you are paying for 2000 rupees for some XYZ units of your consumption, you are paying 2000 rupees. Whether we are ensuring that, whether we are paying this XYZ appropriately. Because let us say the two cases, house number A and house number B, so both of the peoples are using the same type of loads, same type of model of television, same model of refrigerator, same model of UPS, but he is paying 2000 rupees and his consumption is also something, and he is paying only around 250 rupees. Like that means, what makes the difference between these two? Because he will be very happy that I am going to pay only 250, and he is quite anxious. That is, he is also using the same kind of loads. So whenever we are adopting the smart system, what we can able to do, we can able to see, okay, for the 2000 rupees, you can able to see the statement of expenditure. Statement of expenditure means you can able to see you are having the fridge, okay, for that particular month or particular day. The fridge, it is working for 20 days, and the wattage of the fridge is so and so, so you are going to pay the this. Television, it is working for so many hours, and its wattage is so much also, so you're going to pay. The tube light in the bedroom number 3, we are going to operate for so much of hours, its wattage is so much so, and you are going to pay like this. So if you're getting a statement of expenditure, you can able to take a decision. That is, okay, in my house, the people are using a television for a long time. So if I reduce the operation of the television, I can able to reduce the unit price. Or if you're going to see that the tube light, all the tube lights, out of that, one tube light is allowed consuming more amount of energy. That means it may be because of your mechanical choke, or it may be due to the conductor maybe get damaged, or it may be difference in the reactive power. So based upon that, this tube light will give a different set of reading. So not the our energy meter bill, it not only means your consumption alone. Okay, that is the reason what the many people are thinking. Okay, so it will be measuring only the consumption alone, not like that. Along with the consumption, it will also captures the other factors also. Collectively, we are getting the value. So you can able a decision. Okay, I want to change this tube light. So if you take a UPS, so this UPS is making the more number of amount of energy. So I want to reduce that. So the same calculation manually, because in our state we are not having the smart meter. But I have mentioned, because during the COVID time I have taken this survey about my house. Then I found that how to reduce this electricity bill of my house. Okay. So in my house I placed some CCTV cameras. Okay, so throughout my house I'm having a CCTV camera. So and while I'm turning on the CCTV camera, I can able to see that most of the times I'm getting the higher amount of electricity bill. So quite some time I used to turn on the CCTV camera, then I can able to see the amount of unit usage is reduced. And sometimes if I'm turning off my UPS, okay, turning off my UPS after knowing that my capacity is filled, okay, and that time I can able to see the electricity bill is quite reduced. So we can able to take a decision, and also we can able to see that which of the loads are consuming more amount of energy. Okay. So here these are the different advantages, and then the IoT, that's on Internet of Things. Okay, that plays a vital role at present. Okay, that is, we are making use of the IoT based technique. Okay, so based upon that, I will explain you on small case study. Okay, so in this case study, I will explain you how this IoT has been used in order to reduce the electricity bill, or in order to find the fault in your transmission line system. Okay, so this will be helpful for tracking your renewable energy, and also for the effective management of the grid infrastructure, and also for to speed up the information. Okay, so that's IoT. Okay, so here also I will tell you one small story of IoT. So that means, okay, so one of my friends, okay, so his father, okay, so he was with me in US. Okay, his father is in Coimbatore. Okay, so in Coimbatore, in nearby in Perinaikpalayam, so they are having their own petrol. Yes. Okay, so here in this, they are having a petrol bunk. This person was in US, so this petrol bunk was taken by care by his father. So during the night time, you don't know whether the people are working effectively during this petrol bunk. So what he made, so he connected the IoT based devices, and in the US, he can able to watch, because in the US, in the Indian night time will be daytime in US. Okay, so we can able to able to see whether the people are working. He places a camera, so you can able to watch its petrol bunk, whether the people are working effectively. That is called IoT. Okay. So with this IoT environment, so these are some of the advantages of the IoT, that is to avoid the damage and the economic losses. So based upon that, I will explain you one small case study. Okay. So architecture of IoT is about three things. One is called the perception, network, and application. For this also, I will be giving one small story. So this is going to be our last story of the today class. It's a last story. Okay, I can insert one blank slide. Okay, so to explain about what is meant by an IoT. Okay, so normally let us say on human face. Okay, this is a human face. Okay, so let us say that this is the eyes, and this is the eyes. Okay, and this is the nose, and then this is the mouth and ears. Okay, and let us say that it's cognitive things in the human brain. Okay, so how to explain about the working of an IoT? IoT is defined can be with the help of a human face. Okay, so I'm getting a call from Vijay Bhaskar sir. Vijay Bhaskar sir, are you there?
Albert sir, next session starts at 11:30.
11:30.
Next session 11:15 timing. Okay.
Oh, sorry, sir. I thought 11:45.
No. You can conclude now. No problem.
Okay. So after finishing this, I will conclude, sir. Okay.
Okay, sir. 11:15
So
time.
here, okay. So here we can able to see the eyes. Okay. So this is the eyes. It will covers the thing of perception. Okay. So the perception of a person can be received from this eyes. These are called as a sensors. Okay. So these are called as a sensors. So the first layer of your IoT device will be the perception, and then this data will be taken towards your neural. Okay. So that will be called as your network layer. Okay. So this perception in the real-time hardware, we are using the sensors. So the sensors will capture the image or the data, and this sensors will be giving the data to my neuron. And based upon the data what you are received, and based upon the action what you are performing, you are giving the about some person. So for example, if I am asking about any person, means based upon your perception, based upon the network what you are thinking about the person, you are saying about whether the good or bad about the person. This is called as an IoT. Okay, so we can able to understand the IoT as the perception layer, it's having a sensors, and a network layer where I am going to store it. Either I can store it in my brain, I can store it, or I can able to decide it, and finally it's an application layer. Okay, so this particular thing has been captured by our other ones in yesterday class. So I can able to conclude with our time. So next some 2 minutes I can able to answer some queries. Okay, so if you have in my session, because actually I thought it was about 11:45. I'm very sorry about it, but anyhow, if you have any queries, you can put in the chat box, or you can able to answer them.
Sir, will you please share your email ID so that we can, in future, we can contact with you?
Okay. Okay. So I shared in my chat box. You're in your chat box, ma'am. Okay. Okay. So if you have any queries related to this, or if you are interested to work in this area on big data analytics for the renewable energy, you can contact me. Okay. So if you have any queries, you can call me, because I am very sorry for the next speaker, because I captured his 15 minutes. Okay, I'm very sorry about it. So yeah, because usually the session will go with quite a good amount of stories. Okay, so I usually take this engineering along with my stories, starting from the Bohr's atomic model, like a nucleus and the protons and electrons, and even I will explain the buck converter with a story only. Buck converter, the role of inductor in the buck converter. I'll be speaking with the story. So very happy to see you all. Okay, so. I once again thank each and every one of you for your patience hearing, and I once again thank Dr. Vijay Bhaskar sir and Dr. T. Manigandan sir for giving me this opportunity to take this session. Thank you so much. Thank you, sir.
Thank you, Albert sir. Thank you for the presentation, valuable presentation and good presentation also. We got a lot of good feedback from your PPT. Okay, thank you, sir.
Thank you so much, sir. Thank you. Thank you.
Participants, next session will start within 5 minutes. You can reassemble at within 5 minutes. Okay, there is no time, so please all of you reassemble within 5 minutes. The next session starts at 11:40. Okay, thank you. Dr. Suresh sir.
Sir, yes sir, I am here only.
Sir, we will start the session at 11:40, sir. For 5 minutes,
okay.
We will give a break. Okay.
Okay, sir.
Okay, sir. Thank you.
Okay, sir.
Once again. We are organized online test in the second round. What is the timing, duration of the test, number of questions, so that we can prepare accordingly. Time. Particular questions, sir. Validity session வந்துட்டு 2 o'clock start ஆகுது. 2:15 வந்துட்டு क्वेश्चन வந்து ஸ்டார்ட் பண்ணிடுவோம். வேலிடேட்டரிக்கு அப்புறம் क्वेश्चन கொடுத்துக்கலாம். இல்லைன்னா எல்லாம் போயிடுவாங்க.